Hello, this video is for section 7.1, Simplifying Rational Expressions. Objective 2, determine values for which a rational expression is undefined. In the last video, we looked at how to evaluate a rational expression, and now we look at what value makes a rational expression undefined. In practice 2, we looked at how to evaluate 5 over x minus 2. When we plugged in x equal to 2 into our expression, we got 2 minus 2, which is 0 in the denominator. And that is an undefined expression. We cannot divide by 0, so we call it undefined. When asking when a rational expression is undefined, it's all about what makes the denominator equal to 0. Because a rational expression is undefined for those values of the variable, or variables that make the denominator 0, we find the value for which the expression is undefined by setting the denominator equal to 0. If I want to know what makes this undefined, it happens if the denominator is 0. And we solve that resulting equation by adding 5 and dividing by 3. We get x is equal to 5/3. We say that 5/3 is the value that makes that expression undefined. If your denominator is a quadratic function like 3x squared minus 5x minus 2, what makes that undefined is when 3x squared minus 5x minus 2 is equal to 0. Knowing when that becomes 0 amounts to factoring that. And we have to factor 3x squared minus 5x minus 2 in order to figure out when it equals 0. There's two ways to factor that. There's the trial and error, or there's the grouping. Most people like the grouping method. I like them both, so I'll show you both of those. With grouping method, we called it the AC method to add to get B. And so AC in this case is -6 to add to get -5. Our two numbers that work here are -6 and 1. So we replace the minus 5x with -6x plus x minus 2. Factoring out the 3x from both terms, 3x times x minus 2 plus x minus 2. Factor out the x minus 2 to the right-hand side, and we'll be left with 3x plus 1. If you do a trial and error, you know the first in FOIL would have to be a 3x and an x. The last in FOIL is going to have to be either 2 and 1 or 1 and 2. If I do 2 and 1 on the first case, that would be a 3x and a 2x, which could get me 5 if I put the right signs in, but we know since it needs to be -2, we would put a negative on one of them and a positive on the other, and there would be no way to get -5. But if I use it as a 3x1 and an x and a 2, and I put the negative on the 2 and the positive on the 1, then that's -6x plus x, which is -5x, and so that would be the correct factorization. This technique works well on this problem just because the 3 and the 2 are both prime. Now that we have it factored and equal to 0, we set each factor equal to 0 to figure out what makes this 0. We subtract 1 from both sides and divide by 3. So the first number that makes that expression undefined is -1/3, and the other one is 2. So -1/3 and 2 make our expression undefined. Here are a couple of practice problems for you guys to do. If you'd like to do them, I would press pause on the video and then come back and see the solutions. So here are the solutions to it. If I want to know when 3 over x plus 7 is undefined, I set the denominator x plus 7 equal to 0 and solve it and get x equals -7. That's what makes that expression undefined. That one's pretty easy to see because the x plus 7 is easily solved. If you have 3n plus 5 in the denominator, when that equals 0, I'll make the expression undefined. We subtract 5 from both sides and divide by 3, and this time we get -5/3. That makes that expression undefined. And notice how the numerator plays no role in making an expression undefined. So we don't even look at the numerator. Letter C, if I want to know when this expression is undefined, I set the denominator equal to 0, and then I factor x plus 3 and x minus 1. Setting x plus 3 equal to 0, subtract 3 from both sides and get -3. Setting x minus 1 equal to 0, add 1 to both sides and get x is equal to 1. Those are the two numbers that make this expression undefined. In the next video, we will look at how to actually take into account the numerator and simplify our rational expression. Again, this video was Section 7.1, Simplifying Rational Expressions, determining values for which a rational expression is undefined.